this is your next chapter, relation and function. Today I will discuss about the relations only, and in the next I will discuss about the functions. So relation is just the connection between two or more things. So in general language we say that mother and child has a relation, a father and the child has a relation, a husband and a wife has a relation. So the same way in maths also we can relate two quantities. So relating two or more quantities, we use the relation there. So you have used so many statements and things in the maths also, like you have used so many times the relation between the three sides of a right angle triangle, that is known as the Pythagoras theorem. 4 is greater to 3, a number is greater than the other. So this is also an example of a relation. The same way, if L is perpendicular to M, this is also a relation. BA is subset of B, so this is also a relation. So these are the examples of a relation in mathematics. Now, so here we will see what exactly a relation as the definition. So relation A on set A is given as the subset of Cartesian product of A cross A. So here these things you have studied already. Suppose you have A as AB and you're finding the cross product of A. So how many elements you will get there? 2 into 2, you will get 4 elements in A cross A, and these elements will be in which form? They will be in ordered form. So in your A cross A, when you are finding A cross A, so it will be like this. A cross A you are finding, so it will be like this. So here you will get the elements in ordered pair. That will be, the first one will be AB, the second A with A, and then A with B. I'm writing the second one. So BA means this one, and then you will get BB. This one I've missed, so that one will be AB. So now in A cross A you will get this thing, and now this relation A will be subset of this A cross A. Suppose I am taking a relation A, so where I am taking only AA and BB. So this is a relation. Okay, so it can be, generally it is subset of A cross A, the Cartesian product of A cross A, or sometimes it can be same, it means equals to A cross A. That time it is known as the universal relation, when your R will be same as A cross A. So that time it will be known as universal relation. Now suppose if you have two subsets, and two subsets means these two subsets are different, non-empty subsets like A and B you have. So that time they should be non-empty sets, and there also you will say that R will be subset of A cross B. The next one is types of relation. So universal relation I have discussed with you already, and empty is empty relation. So see this one, empty relation means a relation is said to be empty if no elements of A is related with any elements of A. So in R you will get 5 only. An example I am taking, suppose you are a school in which only girls are there. So I am taking a relation R with AB, where A is the brother of B. So there will be no brother because it's a girls' school. So this relation will be empty relation. So the next one is universal relation, that I've discussed already. If the relation R is equal to the same as the Cartesian product, so this kind of relation will be universal relation. So one example, suppose again in the girls' school you have AB. This can be applied to any other school also. So here I've taken the difference between ages of A and B is less than 100. So whenever you're finding the difference between the ages of two students, so that will be less than 100. So you will get in relation you will get all the elements of A cross A. These two are not very important for this chapter. The other three which I will discuss now, these are very important. The next one is reflexive relation. So this reflexive relation is very important for this chapter. What exactly a reflexive means? Suppose you have A and the image of A is also same, and that belongs to R. In ordered pair, suppose you have an element A and its image is also A, and this ordered pair belongs to A, then this kind of relation will be known as reflexive relation. Now in this you have to be sure that every A means whatever the element A contain, every element will have this ordered pair in which the image will be same as the pre-image. Like I've seen this example, A is there, and in A you have 1, 4 and 5. So 1 also have a same image as 1, here also 4, 4, here also 5, 5 you have. So both these are identical, so this is known as reflexive relation. Now in the set A you can see no other element is there, so no other this kind of term is there, so it is reflexive relation. So there can be any other also. And in case when your A is 1, 4, 5 and the set contain only 1, 1, 4, 4, 5, 5, only this much, so this type of relation is also known as identity relation. Reflexive also and identity also. Okay, the next one is, so this one is very important, you will get sums also to check whether it is reflexive or not. Next one is symmetric relation. This is also very important, symmetric relation. In symmetric relation, suppose you have a set from A, you have a relation R that is given by 1, 2, 2, 1, 3, 2 and 4, 4, something like this. Okay, so now in the relation, suppose in a relation you have A1, A2, A1, A2, it belongs to the relation R, and A2, A1 also belongs to R. So this relation is known as symmetric relation. Now in this example which I have taken here, a relation 1, 2 is there and 2, 1 is also there. Okay, so this relation is symmetric relation. Here you can, R is said to be, R is called the symmetric relation if A1, A2 belongs to R, and that implies A2, A1 will also belong to R. So this condition, when this condition will satisfy, then it will be a symmetric relation. And there these A1, A2 both will be from A. Now here again example is taken, so 1, 4, 5, 1, 4 is there, 4, 1 is also there, 1, 5 is there, 5, 1 is also there. So this relation is reflexive relation. The next one is transitive relation. This is also very important. For transitive relation, there is a condition when the relation will be transitive. Suppose A1, A2 belongs to R. Ordered pair A1, A2 belongs to R, and then A2, A3 also belongs to R. So this is the condition, like if A1, A2 belongs to R, A2, A3 also belongs to R. If these two belongs to R, then if A1, A2 belongs to R, A1, A2, A3 also belongs to R, then if your A1, A3 also belongs to R, then it will be transitive. Okay, A1, A2 belongs to R and A2, A3 also belongs to R. That implies that A1, A3 will also belongs to R. That time it will be transitive. Now say this one. And both A1, A2, A3 will belong to that particular set A from which the relation is coming. Okay. So here I have taken one example also, that suppose height of boys is R and A1, A2, A3, these are 3. So here A1 is related to A. The next one is equivalence relation. So our relation R is said to be equivalence relation when R is reflexive, symmetric and transitive. If a relation is symmetric, reflexive and transitive, then it will be equivalence relation. So you will get questions also to prove this equivalence relation also. Now here I've taken one example. Suppose you have a set 1, 2, 3 and a relation is given in the set 1, 2, 3 as this one. So here we have to check whether it is reflexive, symmetric or not. So now you can see in the set you have 1, 2, 3. Now in the relation you have 1, 1. For 1 you have 1, 1. For 2 you have 2, 2. For 3 also you have 3, 3. So that means it will be reflexive. So reflexive, I think it's clear to you. Now next one, you have to check whether it is symmetric or not symmetric. Now for checking the symmetric, we will see here you can see 1, 2 is there, but is 2, 1 is there? No, 2, 1 is not there. So that means it is not symmetric, and you can check it for other also. 2, 3 is there, but 3, 2 is not there, so it is not symmetric. Now you can see the another one, the last one, that is transitive. So here's 1 2 is there, 2 3 is also there, 1 2 is there, 2 3 is also there, but 1 3 is not there, so it is not transitive. So this way you have to check in the sums also whether they are reflexive, symmetric or transitive. So I hope all this is clear to you.